they're found on the top of our mountains, and they're found in lots of species, including our own species. I mean, pre-pandemic times, we were considered to be consuming the equivalent of a credit card in plastic every week. Now, in little over 100 years, they have gone from being miraculous materials to actually being reviled. So initially they were hailed as a scientific wonder. Now they're reviled as an environmental plague and maybe an environmental blight. And yet, on the other side, there's so many societal benefits to plastic. But just some interesting statistics. Less than 25% of plastic is recycled worldwide today. Even in 2021, less than 25%. What you put in your green bins, or what we put in our green bins at home, we're not even sure where it goes. But we know that it shows up on beaches in Southeast Asia, and it shows up on beaches in Turkey because a lot of it is exported. China has stopped accepting this material over the last 2 years. What's even more startling is that 9% of plastic that's ever been made has only been recycled. The other 12% of it has been burnt, and the remaining 80-odd% has ended up in our environment, in our soils, our oceans, our landfills. And we don't have a great record in Ireland because we are the highest producer of plastic waste per person in the EU, and we have the 4th worst track record, according to Eurostat, when it comes to actually recycling. Now, we know a lot about microplastics over the last decade or so. We know that when plastic is released into the aquatic environment, there's physical, chemical, and biological processes that control it. So basically, whether it's a mask or whether it's a piece of plastic, when it ends up in the environment, it's going to fragment and weather and break down. There aren't microbial communities that have evolved yet to actually degrade it, but it will undergo physical degradation, including some photooxidation and UV light that will break down. The plastic particles will sink, they can become buried in the sediments, they can become released. And then the chemical issues. There are many additives or many chemicals used in the production of plastics. These can be released into the environment, while at the same time, the plastics can take up many contaminants in the seawater or in the fresh water that can be absorbed onto the surface of them. We're all familiar with images of birds being entangled or turtles ingesting plastic bags. So they have loads of interactions with biota as well, including ingestion and accumulation and the transfer, potential transfer of those contaminants from the microplastics. Now, the toxicity or the impacts and effects, well, there's a wide range of adverse impacts from ingestion to feeding disruption to reproductive performance, where you get increased infertility. It's been shown at the planktonic level that they can disrupt algal feeding, they can disrupt filter feeding in mollusks, they can cause changes in liver physiology, and they're a source and a vector of organic and inorganic contaminants. And they are also a vector of invasive species and pathogens because they have their own sphere, which we call the plastosphere, because biofilms and organisms that actually live on the surface of them, and if they float and move around the world, it can transport organisms in the very young or larval stages of life cycles to different areas. Now, one of the big issues around microplastics and plastics, and like any contaminant, I suppose, what's key is understanding the source. And this is key to developing reduction strategies and management strategies aimed at reducing the pollution. Pre the pandemic, and it's still debatable, but the 2 main sources of microplastics in the environment were grey water, the water coming out of basically any water from your house other than your sewer, predominantly your washing machine, and again, fibers associated with your clothing. Also, tire and road wear from particles. When your car tire meets with the surface of the road, and the wearing of that is one of the biggest sources of microplastics as well. Then after that, we have things like fishing gear, packaging, cosmetics, not being used as much in cosmetics now. Personal care products, we'll talk a bit more about in a minute. Landfills, wastewater treatment plants, biosolids or treated sludge when it's spread on land, and human litter and litter on our beaches as well. But if we look now at PPE as a source of microplastics, and if we look at one of these disposable blue and white masks, which are considered from the research I've read to be much more effective at the spread of infection, at inhibiting the spread of infection than the woven fibers. If we look at the structure of those masks, they're made up basically of 3 layers. We've an inner white layer close to your face or adjacent to your face, we've a middle white layer, and we've an outer blue layer. So we took these masks at the beginning of the pandemic, and we looked at them using Raman spectroscopy. And I'm sorry now, but the scale bars are very small, but that's what the picture on the upper left is. The scale, I think, is 20 micrometers, the small blue bar down the bottom, and 2 micrometers. So you see these fibers. And when we also looked at the blue layer, we see somewhat similar fibers. And these are non-woven textiles. And then when we look using Raman spectroscopy, we can see that they're made of polypropylene, which much of the PPE is made of. It's made of plastic material. So what do we know since the pandemic? Well, the first thing we know that in England alone, 2.3 billion items of single-use PPE were distributed to the health and social services between February and July of 2020. That's last year. That's the same amount that was distributed throughout the whole of 2019. Globally, 129 billion face masks and 65 billion gloves are estimated to have been used every month during the pandemic. The disposable face market was estimated to have increased from 800 million in 2019 to 160 billion in 2020. And if anything around the usual patterns of disposal is to go by, around 75+% of this plastic PPE waste will likely end up in our landfills or in our ocean and in our environment. And we have seen extensive use of it during the pandemic, together with poor disposal practices. And this is potentially shifting aquatic pollution of this type of debris to be one of the main sources. But at the same time, the magnitude remains somewhat unknown, and we need to include this in monitoring programs to see if this is decreasing or increasing. And basically, in preventing the spread of COVID-19, we can expect a continued use of face masks, despite, I think, the rollout of the vaccination program. Now, also, when we look at sanitary wipes, the production of these non-woven textiles or wipes has increased greatly in the last number of years. They've also shown up consistently as a feature of marine pollution and global plastic surveys, particularly in Europe. And again, microplastics from clothing are generally colored. So a lot of studies have missed out on what we call white or transparent white fibers associated with wet wipes and personal care products. 400% they have increased in our environment in the last decade. This is what they look like on the shore in Galway, down in the Claddagh, from a study we conducted. They form these ropes and they end up in our sewer system, and they combine then with oil from restaurants, and they actually end up generating what we call these fat bergs that block our sewer. Shop Street here in town was dug up the summer before last because the sewer was 75% blocked as a result of these. They also end up in our stormwater systems, and then when we get combined sewer overflows, we end up with these large deposits of this material on our beaches, intertwined with seaweed and seaweed biomass on the shore. Now, you would be absolutely amazed. Myself and some students have gone down and surveyed this material and collected. I was certainly amazed at what people flush down toilets. Even men's disposable razor blades was among the debris that we collected. And this is an example from Wolfetown Bridge, where we have very heavy periods of rainfall in Galway, and the sewer system is connected with the stormwater system. We get these combined sewer overflows. This is one from the lock on the canal near Wolfetown Bridge. And that's how this material ends up, which eventually will fragment and break down into microplastics in our marine environment. Now, as part of our study, we looked at a range of commercial wipes from practically all the high streets, all the major supermarkets, all the pharmacies around. And here up on the top left, you can see what a commercial wet wipe looks like. And when you extract a micro particle from it, that's what it looks like. And then there's one from the beach in Salt Hill. When you look at it using scanning electron microscopy, you can see the similarity between them. And again, when we use Raman spectroscopy to identify both, we find that they are made up of PET, which is polyethylene terephthalate. You can see a macro image down here on the bottom of a field sample of a wipe in a washed up deposit of the sewage material. There is no regulation around labeling. Most flushable wipes are actually made of plastic and not cellulose as they are supposed to be. There's no industry regulation. There's no proper labeling of the material. You see things advertised as 100% water or 100% natural or whatever. Our study has shown that not to be the case. I won't go through this table, but this is the range of products and materials that we found. And we found that the microplastics on the beaches near the wastewater treatment plants were predominantly made up of microplastics from sanitary materials. I think a day or two after our study was released and it made, I think, one of the national papers, two of the larger supermarkets in Ireland came out to say, released a statement to say that none of their wipes were contributing to microplastics in the marine environment or were made from plastic. Well, not actually true, but we had to remain anonymous because of the nature of the study, but that was actually not the case. And the take-home message was do not flush. And just in conclusion, obviously, public health is a priority, but like Maurice said about the impact of climate change, COVID is also obviously having an impact on the health of the planet. And I think we will see a continued use of PPE, irrespective of the vaccination program for a period of time. And as I said, while public health is a priority, we need to start looking at better management strategies to mitigate against the environmental impacts of the pandemic, namely, in this case, the increased use of plastics and their release into our environment. So thank you.
Thanks, Liam, for that. That was very sobering. I will open the floor for questions. Maybe just while we're waiting, Liam, we see a lot more awareness around the issues of single-use plastics and PPE, especially nowadays because of the pandemic. And there's been a huge surge in biodegradable plastics. Now, obviously, I realize that a lot of the material characteristics of those biodegradable plastics wouldn't be akin to what we're used to. So there's some issues with that. But do you think that when we talk about biodegradable plastics, that it's actually a feasible alternative in some instances? Because a lot of those plastics, as far as I know, wouldn't necessarily be biodegradable to the extent that we might expect.
Yeah, that's true. And, there's even been some conflicting reports on actually how biodegradable they are and actually what plastics are used in them. And a lot of the interactions that occur in the environment can be kind of polymer specific. So polypropylene has a specific use. Polyester would be pretty much used mostly in clothing. Polyethylene, and then PVC is a denser plastic, which again has more sinking capability in the environment. But much more research into it in terms of the circular economy, in terms of the waste strategy for Ireland now. An awful lot of it is focusing on looking at the production of greener plastics and also at composting and at composting rates and better improvement. And I think there's going to be a radical shakeover of our entire domestic. In some parts of the country, we have a brown, a blue, and we have 3 bins. In other parts of the country, we have a brown and a blue. And we don't know where that goes. As I said, a lot of our recycled material has been shown to end up in other parts of the world. But we have a terrible reputation for our use of plastic per capita.
Thanks, Liam. I think, Laura, was there a question there? So I have a question here from one of our attendees, Siobhan. Could Ireland become a centre for manufacturing of plastic alternatives in the biodegradable materials, and should more national funding be directed towards research in this area? Are there any plans for this to happen?
There was in the EPA call this year, which closed in July. I mean, Stephen will probably know this better than me, but there were some calls in the circular economy section about bioplastics, and there have been EPA calls, and there's H20 Horizon Europe. It's in there as well.
Stephen, did you have anything that you wanted to add to that?
No, I think that's fair enough. I mean, I suppose the question will come back to where something can be profitably manufactured, and that's probably going to be the issue. But certainly the research is important.
And Liam, we have another question from Irene, who asks, what's the best thing that citizens or consumers can do to force companies to rethink their packaging and products?
Oh, I was hoping that would be what can they do at home. What can they do to force companies? It's well, I suppose it's all about public awareness. And you know, when I'm still working with other contaminants, I think nothing has caught the public imagination as much as the plastic pandemic, if you like, or the plastic crisis globally. It's a good question. I like, you will notice more and more products. For example, Colgate now produce a toothbrush that's made, the bristles are made from a natural fibers, and the handle is made of wood as opposed to plastic. So definitely something is getting through, because you will see more and more products on your supermarket shelves that are made from natural fibers. So I think producers are aware, and I think it's moving in the right direction in that sense. But you know, obviously, if there's a market for this material and sales increases, producers will move to start producing more plastic, more environmentally friendly materials like this.
I think it's a good point, Irene, because the profit is obviously a lot larger for the plastics that manufacturers are using at the moment, because they're cheaper to make than some of the biodegradable and more environmentally friendly alternatives. So pressure from the consumer is obviously one way that could be addressed. Is there any other questions that we have for Liam? I think that's it for the minute. That was really interesting, Liam. I really enjoyed that talk. Thanks so much.
Thank you.
I think we'll pass on to Stephen. Stephen's going to speak to us on the impact of COVID-19 pandemic on GHG emissions, and are these less than expected? Stephen.
I find the mute button. Thanks very much. That's good. Hi everyone, and thanks very much for this opportunity to present on the work the EPA does on measuring greenhouse gas emissions. It's been a long time since I've been in Galway. I think it must be nearly 20 years at this stage, but it's great to be back, even if it's not in an actual room. So I think what I'll do here is I'll just go through a bit of what's happened globally in the last 2 years. 18 months to 2 years, and then look a little bit more specifically at the case of Ireland and what's happened here. So the two things are not necessarily the same, but I think ultimately you'll see that the impact is substantial, but maybe somewhat less substantial than what you might imagine. So there are widespread economic impacts of the pandemic across most sectors of the economy, and the transport sector, the most obviously affected one, naturally, because of the lockdown measures that took place. But it's not the case that all sectors are affected. And for example, there's been no evidence really of a downward impact on agriculture emissions, which actually appear to have increased in 2020. And that's a particular issue for Ireland, because our agriculture emissions are over 35% of our total greenhouse gas emissions, or total reportable greenhouse gas emissions. In terms of the emissions starting to increase again, we are seeing in some countries, and particularly ones where in Asia where the lockdown initially started, where we're seeing as they exit and as they economies start to grow again, and that the relative fuel pricing, in particular, the advantage for coal has meant that there has been a big increase in coal as the economy start to grow again, and that's going to have an impact on emissions because coal is the most carbon intensive fuel in terms of electricity generation, along with peat. So when we get into the global impact, I think this is a bit similar to the view we were looking at earlier in terms of the Spanish flu. We can see that although there was bigger impacts back then, the impact on global energy demand, and this is a slide from the IEA's Global Energy Review from 2020. The impact in the start of 2020 was bigger than anything since World War II, essentially. So bigger than the financial crisis, bigger than the oil shocks in the 70s, and that's as a result of lockdowns on a huge scale and businesses shutting down for a period. But what has happened since then is that things have rebounded sharply. So if we look at the 2021 IEA Global Energy Review, you can see here on this graph on the right hand side that although it hasn't rebounded quite to the same degree, it has rebounded substantially, and it's now only about 1.2% below where emissions were in 2019. So we're almost back to where we were with not a year down the line. And the other thing that you can see, and this is what is lagging really, is the red bar there. Oil hasn't recovered so quickly because oil is the fuel of transportation. But coal has rebounded more strongly, and in particular in Asia, as I was saying, about 80% of the growth is concentrated there, with China projected to account for half of global growth in coal demand. So we are seeing a substantial and very fast response post-COVID in some countries, even as other countries are still working their way through. So the overall impact on emissions is really a blip. This is energy-related emissions, so we're down to around 34 gigatons of CO2 globally, and you can just see we have a slight blip there where 2020 is concerned, but it hasn't really fundamentally altered the direction. I think that's the key point. In terms of the cumulative emissions, you can see here the inexorable rise since we go from 1970 on to 2020, and I think a bit like the plastic situation, Greta Thunberg was speaking about this the other day, that half of all CO2 emissions have happened since 1990. So it is one of those things that just keeps going up and up and up, with intermittent minor shocks as a result of the oil crisis or the collapse of the Soviet Union, things that have a big impact on people's lives and economies, but ultimately don't seem to have any lasting effect on greenhouse gas emissions. And indeed, the latest data from the Mauna Loa Observatory in Hawaii, published by NOAA, highlighted that they haven't seen any discernible signal in the data from the global economic disruption at all, and that the increase in the first 5 months of 2020 in atmospheric CO2 concentration is close to the average annual increase from 2010 to 2019. So no particular evidence at all of a change. And this is kind of to be expected, because what's happened, I mean, obviously the carbon dioxide goes up, it stays up, so it's a cumulative problem. So there's quite a lot up there already, and emitting slightly less for 1 year doesn't have a significant impact on the concentration. In terms of our own data, we've actually been quite busy with the various 2020 data this year. So we brought out with the SCI joint report in January that looked at the impact of COVID on emissions, and using early monthly indicator data, which wouldn't be the normal data used for the greenhouse gas inventory, but tried to give it as early an estimate as we could, using what was available. Then in June, we published the annual greenhouse gas projections report, which would have updated the indicator report using data from the projection cycle and also some actual data where we had it available. But we're not quite done yet. The annual greenhouse gas inventory would be expected to be published in October or November. That's the usual time frame, and we will submit the final version of that to the UN as part of the UNFCCC cycle in next April. What we've seen from the first estimates is that we actually overestimated the effect of COVID in the January report, and the June projections have corrected that back somewhat. And actually even the very latest data suggests that it might be slightly less again in what we publish in the provisional inventory, but not markedly so. So what we're seeing then is overall a reduction in total greenhouse gas emissions, and this is the kind of traditional accounting for what are total CO2 emissions, or total greenhouse gas emissions, I should say, for Ireland, which excludes international aviation most notably, and doesn't include land use emissions in this presentation either, which is the usual approach for international comparison. So actually what's happened in 2020 is essentially the same as what happened in 2019, which was about a 4.4% reduction in emissions. So a substantial drop, and we haven't seen drops of that scale very often. So the last drops that were bigger than that were at the exit of the financial crisis in 2011, and also in 2009 related to the same crisis. The reason 2010 isn't so far down, I believe, is to do with the coldness of the winter. So it does, the weather plays a part here as well, particularly for residential emissions. So yeah, it's less. The 2019 drop, just for reference, was largely due to the reduction in coal being used in electricity generation, and also more renewables on the system. So renewables were up to 38% on of electricity generation in 2019, and also on the agriculture side, there was reduced fertilizer and lime use in 2019, which was really more associated with the drought event of 2018, where a lot more lime and fertilizer had been spread in the hope of achieving some growth. So really the 2019 drop was a combination of once-off effects of ending coal use and a kind of a blip in relation to agriculture that's likely to be reversed in 2020 and 2021. There was also reduced residential emissions in 2019 because of it was a warmer winter. So that's really the scale we're talking of, which is substantial but not outlandish compared to what we've seen before. I'll look at it a bit more detail into the sectors, particularly transport, energy, and residential sectors. But just to show you the full gamut of what we report in terms of sectors, and I won't go into agriculture because it has no real impact. It has no real change. In fact, it increased by about 1%. But no discernible impact from COVID. Perhaps it would have been an even bigger increase without COVID. It's hard to know. Our final agriculture numbers, when we produce them in the next couple of months, will give a better picture on that. The industrial emissions, industrial process emissions, and manufacturing combustion emissions, I'm not going to particularly dwell on either, although they are down substantially. So industrial process emissions down 11%, and manufacturing combustion emissions down 8.7%. So those are two related items. The industrial process is the process emissions. So, for example, from cement manufacturing, the chemical reaction itself, whereas the manufacturing combustion emissions are more the powering the processes. So that's a result of reduced activity, essentially, reduced businesses not operating for long periods, and particularly the carbon-intensive industry such as cement and lime production. Waste emissions, F-gas emissions, and commercial and public service emissions haven't changed very much in what we've seen in these projections. They may be adjusted slightly, but they're smaller contributors in the scheme of things. So let's just look at a bit about the big players. So transport is the biggest one. Transport emissions. This doesn't include international aviation, just to be clear again. This is largely comprised of road transport, and those emissions reduced 14%, which is substantial. The biggest increase you can see in the time series there, in the recent time series, probably the biggest decrease we've seen all along. And transport emissions had been increasing, or in a gradually increasing trend, despite the increase in biofuels, and this was largely driven by increased transport demand, driven by economic growth, and the fact that we haven't yet decoupled economic growth from transport emissions growth. So the drivers behind that, if we look into the fuels, are quite clear. So we can see the big drop in petrol. The first 8 months of 2021 are back up again, but if you see the April 2020 was down 72% on April 2019, so a huge drop, the like of which we wouldn't have seen previously, and that's quite clearly explained by people not traveling more than 5 kilometers from their homes in that period. But we are seeing petrol, and if we look into the diesel one more clearly, that the fuel used, and this is I should say coming from NORA levy data, the National Oil Reserves Agency data on the imports of fuel. So we have a situation where diesel is now back in line with 2019 fuel sales. So that's having taken some time. You can see the different lockdown periods in that graph in 2020 and early 2021, but each time the demand, as soon as the lockdown ends, the fuel sales go back to where they were in 2019, if not even higher. And certainly with, say, freight, we've seen quite a lot of resilience in the freight transport, which you'd see more in the diesel than petrol, obviously, which hasn't quite gotten back up yet. In terms of jet fuel, that still hasn't really moved. Air travel remains highly restricted. We only have data up to the end of June on that, so this may have increased slightly since then, with the vaccine allowing people to travel more. But up until for the most of 2020, it was 64% down on 2019 in total, and 87% down in April, which was the lowest month. So a huge drop off in aviation. As I said, this is not aviation is not included by convention in Ireland's total emissions, because aviation is considered to be a global to be tackled globally. But we do have bunker item memo items in our inventory that highlight the amount of aviation fuel being sold. And you're talking about a reduction of about 2 million tons CO2 equivalent, so a substantial reduction on a global basis, on the basis of the reduction in air travel. Energy industries have also reduced quite dramatically, but as you can see from the graph, this is not something new. This is a continuation of a trend that was there from 2016 onwards. And really, it's not directly attributable to the impact of the pandemic, but it's more to do with the continuing decline in the use of coal and peat in electricity generation. So electricity demand, which will be the driver of this, is actually on balance quite similar. So if you look at the full year, the blue line is the 2020 and the orange line in 2019. You can see that there is on balance a fairly close equivalence between the demand between the 2 years. So it's not a reduction in demand that's driving the reduced emissions. It's more to do with the fuels being used to generate power, and the fact that renewables were also substantially up in 2020. Residential emissions are the one that go the other direction, because obviously people working from home, you'd expect to see an increase in emissions due to more home heating fuel being used, and particularly this was exacerbated by the low cost of home heating fuel in 2020. Excuse me. But there's also a factor here where the weather in 2020 was overall marginally colder, so there would have been a slight increase in emissions expected anyway. But certainly the low cost, particularly low costs around March and April 2020 was a big contributor, and it's difficult to be sure how much of that fuel is actually burnt, because the inventory is based on the fuel sold essentially. So some of that fuel may still be stockpiled, and we might see a downwards impact on 2021 as a result of that. But it's difficult to be sure about that yet. But certainly there seems to be more of an increase than would be explained just by the increase in demand from people working from home. In terms of compliance, and just to touch a little bit on that, the EPA had been highlighting that we were likely to not meet our 2020 targets under the EU's effort sharing decision for quite some time now. This is not the full total of emissions here. This is those emissions covered by the effort sharing decision, which excludes large power generation, basically, in our case, and some other big energy users. So it is still the case that we won't meet the targets for 2020. I mean, that compliance cycle is still underway, but it won't be finished until the final reviewed inventory data is available. But we're going to miss the target cumulatively. It's a cumulative target over the period 2013 to 20, and we're expecting to miss that by somewhere around 12 million tonnes. So it's quite a substantial gap. In terms of what's happening going forward into the future, then we have the situation where 3 lines here. The red line at the top represents our existing measures projection. We do 2 scenarios here, which I haven't really gone into. The blue line is the additional measures projection, which includes everything that was in the 2019 Climate Action Plan, basically. And that shows a reduction of 24% on the 2018 level by 2030. Now, the recent Climate Act has committed to a 51% below 2018 level by 2030. And as you can see, that's about double, bit more than double, in fact, the level of ambition as to what's in the 2019 plan. So there'll be a need for substantial policies and measures to be identified to get to that reduction target. The shaded area, the gap between the targets, if you like, and the budget, and where the existing, where the additional measures, the 2019 plan will get us, is about 100 million tonnes. So it's a substantial gap to bridge. So just to finish up then, as I say, we'll miss the 2020 every-sharing decision targets. In terms of us meeting it by reducing emissions, it's still possible to achieve compliance through purchasing emission allocations from other member states who are prepared to sell them. So it's not that we necessarily won't comply, but we won't have achieved the emissions targets. The estimated emissions reduction in 2020 didn't reach the kind of level that you would expect to see to meet the Climate Act ambition. So I think what that really says is that, you know, we've seen a huge disruption nationally as a result of the pandemic, and what these numbers really highlight is that's not the way to solve the climate problem, because even with that level of disruption, the actual overall impact has been relatively modest. So what's really needed are doing things differently rather than doing less of things. So transformative measures to keep to have any chance really to keep global temperature increase to 1.5 degrees. So that includes things like EVs, but also behavioral change measures, and working from home plays a part in that situation as well. And just, I suppose, my last graph on the National Climate Objective, which is the 51% target to 2030, but also a neutrality target for 2050. It's hard to overstate just how challenging that will be. And I think where people are beginning to see that when the carbon budgets are produced by the Climate Council and the next draft of the Climate Action Plan, just what it will take to get to those levels of reductions. And finally, if you have any questions on this, we're happy to take them in the EPA, and you can also find plenty of information on our website at epa.ie/GHG. Thanks very much for listening.
That's great, Stephen. Thank you so much. There's a few questions that have come through for you. I'm going to field some of those for you now. There's one from Jim Duggan here in NUIG, and he's asked, in terms of energy supply, do you see the pressure to adopt nuclear power as an option will increase as a means to reduce the carbon emissions?
I mean, it's an option on the table. Sorry, I'm not muted. It's an option on the table, obviously, but I suppose there is, if we're talking about the period between now and 2030, it's clear that we have already got very high ambitions for renewable energy, in particular wind, and it's unlikely that nuclear power, if committed to and if that was politically viable, would be in place and operational in that time frame. So I think, although maybe the public debate will mean it will play a part in the future, I think for the period between now and 2030, it's likely that the bulk of the heavy lifting will be done by the existing renewable energy choices.
There's another question. Why did Ireland fail to meet its emission reduction targets? What do we need to do to actually meet those targets?
In terms of 2020, well, we didn't reduce our emissions. So the target was to reduce our emissions by 2020 by 20% compared to 2005 levels, and the actual reduction was somewhere closer to 7%. So the economy grew, and we hadn't decoupled the economic growth from emissions growth as we needed to in order to meet those targets. So I'm not saying economic growth is a bad thing. I'm just saying when you do grow, you need to decouple the two things, and other countries have succeeded in doing that, albeit transport is a big problem for many countries in doing that successfully.
I think you mentioned there at the end about transformative measures, Stephen, and there's a question about that in terms of what we could do on an organisational level to reduce greenhouse gas emissions. So maybe you could comment on what changes organisations could perhaps implement or think about implementing to help reach those targets.
Yeah, and I think most of those measures are, I say transformative, that doesn't mean they're not known. You know, I mean, I think we're talking about things like efficiency of buildings, renewable energy choices, solar power, wind power, but particularly for buildings and organizations, that's where they're going to start. You know, if you massively reduce the amount of energy the building needs, then it doesn't matter as much how you generate it, because you need less of it in the first place. So I think the fabric first approach is obviously a big part of that, and it's not new technology. It's been done for many years in many places, so it's not it's just something that is unfortunately time consuming and expensive to do, and that's probably the key blocker. But that's going to be it's already part of the existing 2019 climate action plan for massive residential and commercial retrofitting programs, and I'd expect to see that increase again in the next plan.
There's also a question from Hamish that says that emission curbs in China are currently leading to all sorts of problems with electricity supply. Industries have to be mothballed and the global supply chain has already been affected by it, and homes are being left without power. Will strong emission curbs in other countries lead to similar disruption? It seems a very unpleasant way forward.
I mean, it's a difficult balancing act to balance the growth in alternative power and then to manage the electricity grid. You know, and we've obviously don't have to look as far as China. We're obviously aware of issues here at the moment in terms of the coming winter. So it's not an easy solution. We do have the options, but they have to be rolled out quickly enough and effectively enough to take over as the old more emitting technologies are phased out. So it's getting that timing right and being able to deploy quickly enough. That's the issue and the challenge.
And just, I guess, Stephen, I'm just wondering, given the link between agricultural practices and what you were saying there about there not necessarily being a huge impact on the COVID-19 pandemic on agricultural emissions, was that something that was surprising for you guys in the EPA, or was it something that would have been anticipated?
Not that surprising, I suppose, because it's not. I mean, the lockdown wouldn't have impacted on farming particularly. We may actually have seen some impact. It's just difficult to quantify in terms of reduced demand for the products because it's a possibility because of restrictions on trade that could be, and there could be an element of that. But we haven't seen something we could identify as being an impact to date. But no, it wouldn't be that surprising because in terms of the animals being on the fields, they were continue to be in the fields and continue to emit methane, for example. So we would be the sector least expected to reduce, and it's probably the main reason why Ireland's reduction is less than other countries, because we have a much higher proportion of agriculture emissions than most other countries.
And in terms of transport, I guess, would you agree or disagree that perhaps we need to look at our practices? I know that, for example, large containers would be shipped from China over to Europe, but a lot of those would be returned empty, which is obviously negatively impacting the emissions. So is there something that's looking at that at the moment in terms of circular economy?
Yeah, I think that is part of it. It's a very important part of the picture. I mean, every efficiency. I mean, the reality is, if you could think of something, could something be done? Then yes is the answer, because everything needs to be done, because the challenges are that difficult, and that I mean, essentially everything you can think of and more is what's needed between now and 2030 and beyond, and new technologies will play a part. So we've at some point even the challenging ambition we have is also relying on being able to soak carbon out of the atmosphere in 2050s and beyond, technologies that aren't proven at that scale yet. So, it's a really, 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 really big challenge. And I think every efficiencies are a huge win. So if it's a case of logistics being more efficient or buildings being more efficient, you reduce the energy need, and that's a huge win. You double. You don't have to get new ways of generating the power if you don't need the power in the first place. So they're the kind of ones that really, really help.
That's brilliant. Thank you so much, Stephen, for that. I'm going to open the floor up for our more extended Q&A session. I think we'll kick it off with you, Liam, if that's okay. There's a question saying that in Thailand, disposable of masks is a real problem with no real advice from the government about what to do with them. Could you advise perhaps on what the best way for an individual is to dispose of the mask?
It's a very good question, because if you remember very recently, they changed in the last 2 to 3 weeks what actually we could put into our green bins. And it's extremely confusing in terms of soft plastics, which I think are considered recyclable, but they're not allowed in when it was to do with something on the conveyor belt. It's like the sanitary wipes. As long as we keep them out of the sewer system and divert them to a different waste management like landfill, and to put them into your non-recyclable bin, is probably the best way of doing it. But there is uncertainty. For example, your till receipt, which we consider to be paper, is not allowed in your green bin. Till receipts are not allowed in your green bin because they're not paper. They're a form of plastic that can't actually be picked up on the conveyor belt at the waste systems. So I advise diverting them to landfill.
Thanks for that, Liam. Moira, there's a question to you that you indicated that future pandemics could be inevitable. I have a feeling I know the answer to this because you often talk about when the next pandemic is happening, not if. So could you maybe expand on that for the attendees, please?
Okay, yeah, well, the reality is that we are at risk of emerging diseases as a biological system, just as much as we are at risk of flooding events or natural disaster events. And I suppose it's something that we would have highlighted, the risk posed to humans by biological systems over the last 20, 25 years. And I think really coronavirus has brought that threat home to us. So the reality is that if we look back at the last 100 years, there's been 4 influenza pandemics, and you'll see in the timeline 1918, and then 1957, 1968, and 2009. So the reality is ongoing. There's constant mutation going on between with influenza viruses infecting birds and pigs. We were looking at H5N1 as a possible source of the next pandemic, and it completely sidewinded us. We were not expecting to see it coming from pig farms in Mexico or the Mexican-US border. We were looking at Southeast Asia. So the one thing we've learned from the world of emerging diseases is it comes where you don't expect it. So the risk factors, and I outlined some of those issues, the reality is that the risks are increasing, and they are interrelated. So you've got issues of increased trade in wild animals, you've got increased animal-human contact, increased urbanization, meaning that if it spills over into a human population, then the spread within highly dense slum areas of Southeast Asian cities is even more difficult to control. And one area that I hadn't actually discussed, and it's also important, is the increasing number of labs that are working on the genetic engineering of high threat pathogens. There is, within the virology world, there is an area of work called gain of function research. And I suppose it came historically from the bioweapon area of work, where defense departments across developed countries were looking at pathogens to see which of those could evolve to become a pandemic threat. And many of these labs are working under stringent biosecurity measures, but we don't actually know. And I suppose there is that underlying query that we will never know the answer to where this particular latest pandemic came from. We don't know. We really don't know. But the reality is that even taking a normal, there is a normal cycle of mutation and adaptation by viruses out there, that it's only a matter of time before we encounter another virus that manages to efficiently transmit from human to human. And things like the mining and logging companies that are encroaching into virgin forests There may be other Ebola virus-like diseases out there. There may be other HIV-like diseases out there. We don't know. We do know that the biological world is hugely diverse, and there are hundreds of thousands of viruses that could potentially affect man. So our role now is, and I think having worked very closely, continue to work with colleagues in WHO, and they have said that coronavirus could possibly be a wake-up call, that if we look at emerging diseases and their mortality rates, if we look at MERS, look at SARS-1, look at some of the other zoonoses that have infected man, their mortality rates can go up to 5 to 10 to 15%. So again, all we've learned in the past 18 months in terms of vaccine technology, in terms of diagnostics, in terms of our animal and human surveillance systems, all of that will stand to us and will make sure we are better prepared. But we also need to be looking at the whole area of climate change and looking at the risk in terms of vector-borne diseases and making sure that it gives additional impetus to the importance of reducing greenhouse gas emissions and reducing global warming.
Thanks, Maura. There's actually another question. Maura, when we talk about Pandem 2, we talk about an EU-wide response system. Somebody posed the question that can we expect a collaboration between the EU and Aviation, the Association of Southeast Asian Nations, in developing a project like Pandem 2? Maybe we could comment.
Well, that's a really important initiative, and it's something that I think the European Union would welcome, particularly as ASEAN countries, in terms of the risk factors of disease emergence and hot zones, they would be at the front line. And we've actually seen some incredibly robust responses from countries in Southeast Asia and in ASEAN in terms of their preparedness from their experiences of SARS and MERS and H5N1. So I think Europe has a lot to learn from ASEAN countries, and I think a global approach is what's needed. And obviously WHO is the key interlocutor there in terms of harmonizing approach and ensuring that developments that have been implemented in Europe in terms of data management or visual analytics or modeling or prediction of future pandemics, that expertise and knowledge is shared. And one of the core parts of our project is the Asia Flu Cap project, which was developed in Thailand by the London School of Tropical Medicine with colleagues in Bangkok, and they looked at the requirements for pandemic response in Thailand and neighboring countries and how countries could share resources. So they were cutting edge there in terms of research coming out of Asia, and also on the emerging disease side of it, there are top end laboratories there looking at animal diseases and monitoring the evolution of pathogens in animal subsets, and then looking at the potential for introduction into humans. So yeah, I would welcome that. And certainly I think the European Union is looking beyond the boundaries of Europe for future research on pandemics.
Well, thanks, Moira. Hamish has a very interesting question to ask all three panelists. First of all, they state that the talks are fascinating and that they would like to ask how optimistic each of the speakers are about the future. Maybe we'll start with you, Liam.
Sorry, can you repeat that? I missed that, Jessica.
So Hamish has posed a question to say that all the talks were very fascinating, but the person would like to ask how optimistic each of the speakers are about the future.
Well, if back, just something that struck me from Maura's slides was you could see the increase in everything that she did. In one of her slides, she showed an increase in everything from 1950. And that actually coincides with stage 2 of what we now consider we're living in as the Anthropocene, or the age of man, as a geological as part of the geological timescale. And everything from greenhouse gas emissions in the atmosphere to globalization to large science foundations, to everything has increased with the Anthropocene, including even numbers of McDonald's restaurants globally. So when you look back, and I suppose most geologists have to look back to actually look forward, it's very hard to be optimistic because of the great acceleration, because of, I suppose, we have we're projected to reach 9 billion people on the planet by 2050. So we see huge population increase again from 1950 onwards. And, you know, increased population means increased demand for food, which means increased requirement of land, clearance of deforestation, what Maura showed us, intensification of agriculture. You know, it's very difficult, even when we hear again, you know, and Stephen referred to it when we talked about, you know, not meeting our obligations under our greenhouse gas emissions, but also maybe not meeting our obligations under the Water Framework Directive and other international directives and treaties, and things that we were supposed to have, statuses that we were supposed to have reached by 2020 now being postponed to 2070 and 2027 and 2030. One is always hopeful, but it's, you know, realistically, it's hard to be optimistic.
Yeah, I think a lot of onus has been put on personal responsibility, but I do wonder if that kind of detracts from, I guess, national and international responsibility, and whether we need to take a hard look at ourselves and as nations to see if we're actually doing enough. And a lot of these deadlines and so on that are put forward, is it really going to be enough, considering we're working with a finite resource, really? Perhaps, Stephen, you could answer how hopeful you are feeling for the future.
Yeah, I suppose I think we'll get there. In terms of climate, I'm thinking of this particularly here, because I think we know, or we can at least map out what the route is. I think for the most part, it's not reinventing the wheel. There are some cases where it is, but it's not in general. The question is really about the appetite and commitment at political and individual level. Well, individual level, I think, does drive the political appetite as well, so it reinforces it. But I do think that we're starting to see, as we get into actually seeing the impacts of climate change on the ground, whether it's pandemic related or whether it's floods and other natural disturbances, I think people are more and more seeing the effects, and I think that is what's going to really drive the appetite to get the job done. So yeah, I think technologically we can do it, and I'm not saying we're definitely going to have it done by 2030 either, but I think we'll get there.
Maura, do you have anything to add to that?
I think the one thing COVID-19 has shown us is how resourceful we are as human beings, and how, when things weren't possible, we can adapt our healthcare systems or laboratory systems or communication or work practices. It was phenomenal in how we've responded to it across Europe. I think the big issue is the population increase, that the level of population growth, it is unsustainable. And I think that it's a very hard discussion, and I think it's something that needs to be taken on board, in addition to the focus on greenhouse gas emissions. I would be inherently optimistic. I think the groundswell of activism among the younger generation is really positive. I think that it's a hard road, and we've got to completely revisit how we structure our society and our economies, what we reward, what we focus in terms of outputs and economic growth. We need to be looking at a completely different way of measuring well-being and human population, how we live. And that includes things like cycleways, it includes working from home, it includes incorporating into our everyday life approaches that reduce the impact on our planet. So I would be optimistic, but it's a hard road, and it will take a lot of action by everybody. And I think it's about individual level responsibility, but it's also at the highest level. And I think it's remarkable what has been achieved in the last 5 years, but that momentum needs to be continue. There needs to be continued pressure on the monitoring. And I think hats off to the work that's been done by the EPA. It's, if you're not measuring something, you don't know where you are. And look where we are now compared to 10 years ago. So this is a hugely important, the monitoring of the impact of climate change on the planet is revolutionized. And the way in which we share that information and make it available, and we're measuring down individual sectors. So we need to make sure that the economic imperative and the purpose, the whole thing of GDP and measuring societal success on the GDP or the output, that needs to be turned on its head. We need to ensure people have an economic livelihood and ability to earn a living, but it has to be done in a holistic context of making sure that we protect the planet's health as our human population continues to grow.
And Moira, just finally, there was a comment that I would like to give you a chance to clarify on, that there's no evidence that SARS-CoV-2 originates from gain-of-function research. It's important that we have clear responsibilities towards the environment and not to try to blame any secret military operations for our shortcomings. So I just want to give you a very brief chance to clarify.
No, there is no evidence that SARS-CoV-2 originates from a gain-of-function research. So I was given an example of laboratories around the world that are working on high-impact pathogens. Our absolute responsibility is to ensure, and these are state, they're not necessarily military, they are state laboratories that are working on research. And in ways it's to protect human populations, to develop interventions that would prevent the spread. I mean, a lot of the monitoring of the threats out there is looking where pathogens could develop to become infectious to man. So absolutely, our responsibility is to try and protect the environment, to reduce the impact, the potential for zoonotic spillover into human populations. And within that, it also includes ensuring strong biosecurity regulation in place at an international level across the world. And WHO is looking at that, given the increase in numbers of labs and how that technology is becoming much more available now than it was 10 years ago.
So I think we are at the point that we can finish up our Spotlight series for today. I just want to extend my immense gratitude to Liam, to Stephen and to Moira for taking the time to present and discuss the pertinent issues around climate change today. And I'd like to also extend my gratitude to Mohan and the communications team in the Rhine Institute and the Centre of One Health, and as well as CAR Communications that works tirelessly on the Pandem 2 project. Thank you so much for helping this event happen so smoothly today. And for anybody that's interested in learning a little bit more about what we're doing Pandem 2, you can reach us on our website or sign up for our newsletter. I wasn't going to get away with not saying that because the guys in CAR Communications will give out really badly. But thank you so much, everybody, for your attendance today. And this will be available on the Centre of One Health YouTube channel. Thank you.
Thank you.
Thank you.
Thank you, everybody.